Hello friends, today's topic is series bias clipper. If you have watched my previous video, you will be able to solve parallel clipper in a minute. Same way, today's series bias clipper is also easy. If you still not learned parallel bias clipper, I will provide you link in the description box. So watch it first and then come to this video. Let's start. So first of all, consider unbiased series clipper. So the diagram of series clipper. So positive series clipper without bias, negative series clipper. So in case of series, diode and R both are in series. Diode and R both are in series. So in positive clipper, positive part is not present. In negative clipper, negative part is not present. Means in positive clipper, positive part is 0. In negative clipper, negative part is 0. So in case of bias, the first topic is positive bias series clipper. So in this clipper, one bias will be added to diode in which series. So there are two possibilities to add bias in series. So left plate towards diode, or positive means left plate, negative plate towards diode, or positive plate towards diode. So consider about the first theory. So the same way as the parallel clipper, first of all you have to consider that there is no any kind of input voltage present over here. So consider only bias voltage. So here anode and cathode. So consider there is no voltage at input. So anode is equal to 0, cathode is equal to minus. So initially cathode is equal to minus, anode is equal to 0. So anode is positive compared to cathode. So D is on when input is equal to 0. When D on, draw the equivalent diagram. So the equivalent diagram of these two over here. So the battery is plus minus 1 volt, and when diode is on, the anode plate is plus, cathode plate is minus. So in this diagram, minus 1 plus 0.7 is equal to minus 0.3 volt. So there is no any kind of input, still minus 0.3 volt output, because this is a starting point of your waveform. Means your waveform is start from minus 0.3, not 0. So your waveform is start from minus 0.3 volt. This is your starting point. So next, consider for the positive half cycle. So in positive half cycle, initially D is on. So in positive half cycle, plus 1, plus 2, plus 3, plus 4, plus 5. So up to 0.1, 0.2, 0.3. When 0.4, so 0.4 is positive, means in positive half cycle, upper part is plus. So 0.4 plus, and this minus 1. So subtraction from 0.4 and minus 1 is 0.6 volt. So diode is off. So after 0.4, 2 plus 5 and plus 5, 2.4, your diode is off. Means in this case, in series configuration, D is off, so circuit will be open. So output is equal to 0. So up to 0.4, 0.3 will be there. So this 0.3 will reach at to 0. Up to the input is equal to 0.4. After 0.4, D is off. So D off means there is no any kind of D is available. So open circuit. Open circuit means D is off. So D is off, so output is 0. When again the latter part, the 0.4 voltage is reached. So 0.4, 0.3, 0.2, 0.1 and 0. D is on. Again it will reach at to the minus 0.3 level. So up to 0 volt is equal to again minus 0.3. The same calculation of equivalent diagram. So in negative half cycle, your negative voltage is like that, minus plus. So plus minus plus minus. So series addition, and cathode is minus, and anode is equal to 0. So all negative half cycle, your diode is all in negative half cycle, your diode is on. Means the diode is on. So now you have to calculate the all voltage sources, means input source, bias and diode. So in this case, plus minus, plus, minus, and minus plus. So diagram behave like that. Five volt plus minus 1 volt and minus plus 0.7 volt. So upper sign is minus because negative cycle. So minus, minus, plus. So 5 plus 1, 6. 6 minus 0.7 is equal to 5.3. So your waveform start from this voltage and it will go up to the minus 5.3 and it will reach up to again minus 0.3. So your peak amplitude of your negative cycle is 5.3. Why 5.3? Because your last voltage level is minus 0.3. In negative cycle 5 volt. So you just add 5 to 0.3. This is a minus 5.3. So in the second configuration, consider the anode and cathode. So cathode is plus 1. Anode is 0, definitely D off. D off, open circuit, output is equal to 0. So in this case, initially input is equal to 0, D is off. So your waveform is start from 0 because D is off. D is off means the circuit is open. So there is no any kind of output voltage present across load. So in all positive cycle, cathode is positive because 0, plus 1, plus 2, plus 3, plus 4, plus 5. Anode is lesser than cathode. So in whole positive cycle, diode is off. So in whole positive cycle, output is equal to 0 volt. So consider about the when D is on. So in case of negative cycle, anode in case of negative cycle, so negative cycle consider then minus plus. Initially minus plus. So plus minus minus plus means bias is opposition with your supply voltage. So in case of when you applied one voltage, so plus minus minus plus both are in opposition, so out total voltage is 0. So after which input voltage diode is on. So consider that in minus cycle, when cathode is equal to minus 1.7 or minus 0.7 is equal to and anode is equal to 0, at that point your diode is on. So in this case, up to minus 1.7 your D is off. So up to minus 1.7, so consider this is a minus 1.7. So up to this point your D is off means diode is open circuit, so output is equal to 0. When D is on, so when D is on, the equivalent diagram like that. So consider the upper sign minus 5 plus 1 plus 0.7. So average voltage is 1.7 minus 5, so minus 3.3. So your waveform will peak up to minus 3.3. So your waveform is peak up to minus 3.3. Again it will reach it to 0 when input is equal to minus 1.7. Again 0 voltage is constant. So peak amplitude of your negative cycle is minus 3.3. This is a simple calculation. Your diode is start from minus 1.7. So you can just neglect 5 minus 1.7 is equal to minus 3.3. So in case of negative series clipper, first of all, negative clipper means negative is equal to 0. So when you add any kind of bias supply, so series with the diode. So first of all, consider the minus plate towards diode and then consider about the plus plate towards diode. So in this case, first of all, consider that the terminal is anode and this terminal is cathode. So initially when consider is any kind of input voltage is present, so input is equal to 0. So minus 1 apply to cathode, so definitely D is off. D is off means circuit is open, so there is no any kind of voltage at output side, so output voltage is equal to 0. So your waveform will be start from 0. This is your starting position of your output waveform. So consider initially D off, so think about D on. So in positive cycle, consider that in positive cycle supply voltage is positive, so plus 5 volt. The bias is opposite of your supply voltage 1 volt. So minus plus plus minus. So input, so your bias is subtracted from your input. So when equal to 0 point, minus 1 voltage at anode. When input is equal to 1, so 1 and 1 each other cancel, so anode is equal to 0. So definitely your diode is start from anode is equal to plus 1.7, because plus 1 voltage is subtracted from bias and 0.7 is applied to anode to turn on this diode. So up to 1.7 diode is off. So up to 1.7 like that, this is a 1.7 voltage. So projection on your T line timeline, this is a 0 voltage. So it will reflect over here also. So when your diode is on in positive cycle, so consider this diagram is equivalent diagram of your diode. So plus 0.7. So averaging of this voltage is 5 minus 1 minus 0.7 is equal to plus 3.3. So as explained in the previous circuit diagram is 3.3. So plus 3.3. So your waveform will be started from 0 to plus 3.6. So your peak voltage is plus 3.3 voltage. So 1.7 plus 3.3 is equal to total 5 voltage. So in case of negative cycle, anode is minus, means anode is negative compared to cathode. So definitely D is off. So in whole negative cycle, output is equal to 0 because D off, so open circuit. So in the next configuration, initially same as consider input is equal to 0, then think about the bias voltage. So definitely first of all anode and cathode. So D is on, then draw the equivalent diagram. So equivalent diagram of bias and diode. So plus minus 1 voltage and plus minus diode voltage, means diode is on. So plus 1 minus 0.7 is equal to plus 0.3. So when there is no input present in the circuit, plus 0.3 volt present at output. So your waveform is start from plus 0.3 volt, not 0. So your waveform is start from somewhere like that 0.3 volt, but sign is plus. So consider about the next point. So in the positive half cycle, when you apply plus minus, so minus plus minus plus both are in series, so addition, and anode is always plus. So in whole positive cycle, D is on. So D is on. So your waveform is start from plus 0.3, not 0. So your waveform start from 0.3. So your waveform is reach at plus 5.3. So the maximum amplitude of your waveform is 5.3 because your waveform is start from 0.3, not 0. So 0.3 plus your input voltage 5. So 0.3 plus 5 is equal to 5.3. Again, it will reach at plus 0.3, not 0. Plus 0.3. So after the second cycle means the negative half cycle. In negative half cycle, consider minus plus. Initially, you have to apply 1 volt. So plus minus minus plus. So both source each other cancel. So anode is equal to 0. So D is off. So up to this voltage D is off. So up to some input voltage of negative cycle, your diode is off. Then when diode is off, so your output voltage reach to the 0 level. So when your diode is off, so consider plus 1 bias supply is fixed. So draw the equivalent diagram of bias supply with input. When input voltage is minus 0.4 and your bias will be fixed 1 volt. So plus minus minus plus. So consider the calculation minus 4 plus 1 is equal to plus 0.6. So anode is equal to plus 0.6. Basically, anode is require minimum voltage of 0.7 volt. So minus 0.4 is equal to D off, and D off your output it reach to 0. So this point is voltage is approximately equal to minus 0.4 minus 0.4. So in whole negative cycle, the minus supply is minus 1, minus 2, minus 3, minus 4. So anode is minus. So in whole negative cycle, anode is minus, so D is off, then open circuit. So open circuit, your waveform will be 0. So using this, you can draw the waveform. Thank you for watching. If you get this video informative, then stay connected for more such kind of videos. Thank you.